Good morning and welcome to all of you who are watching right now. Today, what we're gonna do is we're gonna continue on with chapter 7, and we are right now on lesson number 6. So what we've been talking about are trig identities. So just to kind of refresh our memory, just it's been a while since we talked about it. This is where we were. The In terms of identities, we talked about reciprocal identities. So these are reciprocal identities. They're all found on page 9. We talked about quotient identities, where tan is sine over cos and cotangent is cos over sine. And lastly, we talked about the Pythagorean trig identity, where it's going to be cos squared plus sine squared is equals to 1. There's talked about the variety of that one. So what we're gonna do is we're just gonna continue on with this and chapter 7, lesson 6. So we're on page 15 right now. Okay. So let's go right in here. Example 1, right on to the example. So solve each equation over the domain of 0 to 2 pi. Over the domain of 0 to 2 pi. Okay, that one stop. I'm just gonna grab a pencil. That one doesn't work. Okay, so 3 cos x plus 1 is equals to 2 times secant x. So what can we do? In this particular case, we have cosine and we have secant. So I think the best way to get started is to write down what's an identity for secant. So we know that secant is 1 over cos of x. So we know that something like that. So what we're going to do instead of using secant of x, we're going to use 1 over cos of x to replace that. So it becomes 3 cos of x plus 1 equals to 2 times 1 over cos of x. And of course, if we multiply this is just going to be basically 2 divided by cosine of x. Okay, so how do we do this? We have the left side and the right side. Because we are solving here we are solving. We're not proving it. Okay, so because we're solving, we can switch side on each side of the equation. Okay, so what can we do? The very first thing that I would suggest would be to get rid of the denominator. So let's get rid of the denominator. How do we get rid of the cosine in the denominator? So to do that, what we're going to do is we're going to multiply cosine of x on both sides of the equation. So we're going to multiply cosine of x on each side of the equation. Okay, so what happened is this cosine of x divided by cosine of x, that will cancel each other out. So we have just a 2 in there. And then over here, we're going to end up with 3 times, cos squared of x. Cos squared of x plus, so we multiply it in right there. And then cos of x times 1 is just going to be cos of x. Okay, so this is where we are at. Okay. So what's the very first thing that we did was to transfer or substitute 1 over cos of x in place of secant of x. And then the next thing that we did was to multiply cos of x on each side to get rid of the denominator. Okay, so that's gone. And then cos of x times cos of x is cos squared of x. Now we're going to end up with a trinomial in here. Okay, so this is going to be a quadratic equation, trig equation. So bring this 2 on the left side. So that becomes 3 cos squared of x plus cos of x minus 2. Now we've seen something like this already before. So this is nothing new to us. So how can we factor this out? So we have 3 cos squared of x and then plus cos of x minus 2. So this is going to be a quadratic. So we're going to have a trinomial in here. Let's see if it's factorable. So the very first thing is, let's see if it's factorable. I kind of gave it away in here because I've already have the 2 brackets. So what we can do, okay, well, how can we get a 3? 3 cos squared of x. So I can get 3 cos of x times cos of x. So that's that one. 3 cos of x times cos of x is going to give us 3 cos squared of x. And how can we get a negative 2? But then if we expand it, we're going to get a 1 in the middle term. So that becomes, this is going to be plus 1, and then this is going to be minus 2. Okay, so that if we, let's just see, 3 cos of x times 1 is going to be 3 cos of x. And then here, this is a minus 2 cos of x. So we're going to end up with a plus 1 cos of x. And then if we multiply these two, it's going to give us a negative 2. Negative 2. Okay, so now that we have a factored form, we can solve for x. So for this particular case, we can say cos of x is equals to 2/3. Okay, so cos of x is equals to 2/3. And then this part here, cos of x is equals to negative 1. Negative 1. So what we're going to do, okay, well, let's visualize this. Let's visualize. Visualize. Because we want to see our answer, not just solve it, but actually see it. So now here, cos of x, cos of some angle will give us 2/3. Well, what is cos? I'm just going to write down our unit circle. Okay, we're so familiar with this right now. Where is cosine? Where is cosine positive? So it's cosine is positive in quadrants 1 and quadrant 4. So this cos of x have 2 possible solutions. It can be found in quadrant 1 and in quadrant 4. Okay, so how do we do that? So cos of x equals to 2/3. So x is equals to the cos inverse of 2/3. The great thing about this is, oops, sorry, you can't see that. Okay, let's bring it down a bit. The great thing is because this is a positive and an answer is in quadrant 1, that would also give us a reference angle. Reference angle. Okay, let's go take a look at our calculator. Make sure it's in radian mode because it's talking about radian. So cos inverse of 2/3, 2/3. It's going to give us 0.84. Okay, so that means this is 0.84 and this is a 0.84 as well. Okay, so in quadrant 1, okay, x is equals to 0.84, and in quadrant 4, it's going to be x is equals to 2 pi minus 0.84. 2 pi minus 0.84, which is 5.44. And these are all radians. So if we can put the r, little r there. So that's the answer for cos of x equals to 2/3. Now, what about cos of x equals to -1? Well, where is cos -1? Here. Let's see. Where can we put it? Okay, let's put it right here. Cos of x equals to -1. Well, where is cos -1? Cos is -1 here, right? So this is where cos is -1. So if you want to do cos of -1, it's going to give us a pi radians. So this is going to be pi radians. Okay, so we have three solutions. Three solutions in this particular case. So the solutions are x is equals to pi, so that's that one, when cos of x is -1. And when cos of x is 2/3, we got two solutions for that, and it's going to be 0.84 radians and 5.44 radians. Okay, so there you go. So if you're just joining us just now, so of course I'm gonna post all of the notes later. Okay, so don't worry. And then of course you can always rewind the video and rewatch the video to see this part. Okay, we're gonna take a look at letter B. So letter B, how can we do this part here? So 2 cos squared of x minus 3 sine of x equals to 0. So what can we do? How can we solve this equation? The thing about this equation is that it has both combination of sine and cosine. Okay, so that's a challenge in here, is because we have some cosine and we have some sine. So what can we do? What can we do? What can we replace? Okay, so what we could do is we can replace, okay, we can replace cos squared of x by 1 minus sine squared of x. So we know, okay, I'm just going to write this down here. Using our trig identity, we know cos squared of x is equals to 1 minus sine squared of x. Okay, so having this identity, we can transform this equation to just strictly sine. Okay, so that's a great thing about that one. Okay, so let's do that. So instead of cos squared of x, we're going to use 1 minus sine squared of x. What would that look like? It becomes 2 times 1 minus sine squared of x minus 3 sine of x equals to 0. Okay, so now it's already kind of looking good, having just a sine squared of x. So we multiply it in. 2 times 1 is going to be 2. 2 times negative sine squared of x is going to be negative 2 sine squared of x, and then minus 3 sine of x equals to 0. Okay, so that's great. What can we do next? Well, let's see if we can put it in order so that it's kind of looking like a trinomial, right? A trinomial equation. So let's put this in order. So it's going to be negative 2 sine squared of x minus 3 sine of x, and then plus 2 equals to 0. Okay, great. So what do we do next? Okay, well, what I'm thinking about is we can either multiply everything by 1 or, sorry, multiply everything by -1 to get rid of this negative in here. Okay, so that our trinomial starts with a positive 2 sine squared of x instead of a -2. Or you can say we can divide it by -1. It doesn't matter. I'll just say multiply everything by -1. So that becomes 2 sine squared of x plus 3 sine of x minus 2. Okay, so we multiplied everything by -1. Okay, so now I can see here, we got a trinomial. Let's see if this is even factorable. 2 times -2, that's going to give us a -4. And then any factor of -4 that results a +3. Yeah, we can have a +4 times -1. So yeah, it is factorable. So it is factorable. So how do you get 2 sine squared of x? To get 2 sine squared of x, I can get 2 sine of x times sine of x. Okay, so that's going to give us 2 sine of x times sine of x is going to give us 2 sine squared of x. How are we going to get a -2 that when we expand it, it will become a -3? I'm sorry, +3. So we can go a +2 here and a -1 there. Okay, so that we've factored it out. So we can just take a look at each one. We're going to use a zero product property, which we learned a long time ago in grade 10 and 11. So we go sine 2 sine of x minus 1 equals to 0. So sine of x equals to 1/2. Okay, so sine of x is equals to 1/2. And then we're going to take a look at this part here. And then this part here, we're going to get sine of x equals to plus 2 equals to 0. So sine of x equals to 2. Now, where is sine of x 1/2? Well, where is sine of x 1/2? Let's see if visualize that. Now you're probably thinking that is going to be a special triangle because sine of x is 1/2. Where is that going to be? Okay, well, first of all, where is sine positive? So sine is positive in quadrant 1 and quadrant 2. Okay, so where is sine 1/2? So that if you go here, sine of x equals to 1/2. That's a special angle. I'll just go like this. Special angle, x is equals to pi by 3. No, pi by 6 rather. Pi by 6. So this is pi by 6. That's the reference angle. So this is pi by 6, a reference angle. And then this is a pi by 6, another reference angle. Okay. It's basically pi by 6 there and there. Reference angle. So the next one would be, if this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So the other one would be 5 pi by 6. Okay, so we got 2 solutions for that one. Okay, now what about this one here? Sine of x equals to 2. Well, where is sine 2? Sine 2, that's going to be no solution. No solution for that one. So x is no solution. Okay, so just to kind of see what that is, let's try it. So sine inverse of 2, then you're going to get an error. Okay, error. Now, why is that? You're probably thinking, why is that? Is there a way for me to figure that out? Um, why there's no solution? Okay, remember that sine is opposite over hypotenuse. Opposite over hypotenuse. So that means opposite side is 2, hypotenuse is 1. This doesn't make sense because we know hypotenuse is always the longest one, right, in a triangle. So um, in this particular case, there's no solution because um, hypotenuse is 2, opposite is 1, which doesn't make sense. There's no such triangle for that one. So these are the only two solutions. Pi by 6 and 5 pi by 6. Okay, so that's that. Let's moving along. Okay, at some point, like you can just take a listen, write things down if you are writing things down right now. And if you have any questions or concerns, just let me know or send me an email. Then I'll respond back as soon as I can. Okay, so let's go ahead to question C. Let's take a look at question C. 2 sine of x equals to 3 plus 2 cosecant of x. Okay, so what do we know? So the problem in here is that they have sine of x and then you have a cos of x. So what can we do? What can we do? Well, what do we know? Let's see here. Well, we know that cosecant of x, cosecant of x is equals to 1 over sine of x. Okay, so this is our trig identity, and that's what we're going to use to replace this one. Okay, so what can we do from here? Well, let's go there. 2 sine of x equals to 3 plus 2 times 1 over sine of x. Okay, like that. And so, well, we don't want the sine of x in the denominator in here. So what we can do is we can, let's rewrite it first. So we need to get rid of the sine of x in the denominator. So how can we get rid of the denominator? So we multiply each term or in each side of the equation by sine of x to cancel this sine of x in the denominator. So let's do that. Sine of x, and I have to multiply all of these by sine of x. Okay, so what's this gonna look like? Sine of x. Okay, sorry, sine of x times 2 sine of x. That's gonna give us 2 sine squared of x. It's gonna give us 2 sine squared of x equals, and then this is a binomial times sine of x, so I have to do multiply in. Okay, so it's going to be sine of x times 3. That's going to give us 3 sine of x, and then sine of x times 2 over sine of x, and this is going to cancel that one, so that's going to be just a 2. So it's kind of nice. Now we're going to see a familiar thing again where it says a trinomial. So if I move this all of these on the other side of the equation on the left side and then get the 0 on the other side. Let's see if it's even factorable. Okay, so 2 sine squared of x minus 3 sine of x minus 2 equals to 0. Okay. So is this even factorable? Yeah, let's see. How can I get 2 sine squared of x? I can get 2 sine of x times sine of x. That's going to give us 2 sine squared of x if we multiply these two. And then what about this one? I have a negative 2, but if we expand it, it should be a negative 3 in the middle. So what can we do? I can go negative 2 in here. So that's going to give me a negative 4 and then plus 1. So that's going to give me a positive 1 there. So it will give me if I do expand, it's going to give us a negative 3 in the middle. So let's take a look at this one again. 2 sine of x plus 1. That's going to give us 2 sine of x plus 1 equals to 0. So that means sine of x is equals to negative 1/2. And then we have to ask ourselves, where is sine of x a negative 1/2? Where is sine of x negative 1/2? That's going to be if we have a unit circle, negative 1/2. So that's going to give us right here in quadrant 3 and quadrant 4. So because this is a negative 1/2, let's take a look at the reference angle. Let's find the reference angle. So what we're going to do, sine of x equals to positive 1/2. Okay, that's just to figure out the reference angle. Reference angle, bring it closer. So reference angle is equals to the sine inverse of 1/2. Okay, let's see. Sine inverse, and you probably know what that answer is already. It's going to be pi by 6. Okay. Sine inverse of 1/2. Okay, so that's going to give us pi by 6. So that means that this is pi by 6 and then this is pi by 6. Okay, this is really tiny. So this is pi by 6 and then this is pi by 6. So if I go pi by 6, so that's going to take us to 7 pi by 6. So therefore, x is equals to 7 pi by 6. Okay, so this is 7 pi by 6, 8 pi by 6, and this is going to be 11 pi by 6. 11 pi by 6. Okay, so that's that. And then, well, what about this one? Let's see about this one. Just put it right there. What about sine of x? Sine of x minus 2 equals 0. So that means sine of x is equals to positive 2. So same thing, when you take the sine inverse of that, same thing as what we had last time. If we take the sine inverse of that, we're going to get a an error, so that means there's no solution there. No solution. So that means the only solution that we have, are these. Okay, so let's see. Let's go to this one over here. Now this one is, oh, I'll give you a moment to copy that down or write that down. Okay, so I hope you're finished copying that down, and then we'll go to letter D. So letter D looks like this. So sine of x plus root of 3 cos of x equals to 0. Okay, how do we do that? Well, there is really no identity between sine of x and cos of x. It's not sine squared of x, or it's not cos squared of x. So in terms of identity, so what can we do with this one in here, right? Because there's no identity that just do that. Okay, well, what can we do? Well, what if we just put this on the other side? Let's see here. Sine of x plus root 3 cos of x equals to 0. So if we bring this to the other side of the equation, it becomes sine of x. Okay. And then we're going to bring this to the other side. So that's going to be negative root 3 sine, root 3, where's my eraser? Root 3 cos of x. Cos of x, okay. Well, what good is that to us? Let's see. Oh, what we can do is the next thing we can do is we can divide by cosine of x, divide by cosine of x. What's created in here if we divide by cosine of x is that the cosine of x cancels, so that's a great thing. But at the same time, this could be an identity. This one, sine of x divided by cos of x, is tangent of x. So that's a great thing. So we can replace these two with just a tangent of x. So tangent of x equals to negative root of 3. Now, where is tangent of x is root of 3? Let me see here. Let me see. Create a, and it's a negative root of 3, okay? I'm just going to write down some basic angles in here. So this one here, this is pi by 6. And at pi by 6, that's going to be 1/2 comma root 3 over 2. And then this one here is root 2 over 2. Oops, sorry, you can't see that. Root 2 over 2 or root 2 over 2. And then over here, that's going to be 1. I got these two backwards. Back up the bus. So this is going to be root 3 over 2. Yeah, x is root 3 over 2 and then 1/2. And then this is going to be 1/2 root 3 over 2. Okay. So this is basically the first few angles in quadrant 1. Now, remember that the x coordinate is the cos of the angle, And then the y is the sine of the angle. So what is the tan of the angle? Tan is sine divided by cos. So if I take in this particular angle, for this angle, I can go 1/2 sine of this angle is 1/2 divided by root 3 over 2. So the 2's cancel, and then that's going to be 1 over root of 3. So the tan, in this particular case, tangent of pi by 6 is 1 over root of 3. Now, this one is pi by 4. Pi by 4. And what's the tangent? Sine over cos. So that's going to give us 1. Now, what about this one? That's going to give us pi by 3, and cosine is 1/2. Sine is root 3 over 2. So that means the tangent is going to be tan of pi by 3 is equals to root 3 over 1. Now, as you can see here, this is going to be just root of 3. But this is negative root of 3. So where is the tangent negative root of 3? So tangent of negative root of 3 is going to be here and in here. Okay, so it's, where is tan negative? I'll write it down in here just in case. Where is tan of x negative? Well, it's going to be in quadrant 2 and quadrant 4. So that's where it is, right there, quadrant 2 and quadrant 4. Our reference angle is pi by 3. So that means this is a reference angle of pi by 3. And then here's a reference angle too, also by pi by 3. Okay, so where is this one? So therefore, in quadrant 2, okay, x is going to be 2 pi by 3. 2 pi by 3. And then in quadrant 4, x is equals to 2 pi minus pi by 3. So you can do the calculation there, or you can just count up. So this is pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3. Or you can do 2 pi minus pi by 3, which is 5 pi by 3. So we got two solutions there. Two solutions for x. So x is equal to 2 pi by 3 and 5 pi by 3. Okay, so yeah, that's it for today. I don't want to continue on, like, we got some time, but I don't want to continue on with the rest of these stuff. We want to make sure that we practice. Okay, so we got these practice questions on page 616, question 10 and 12. 10 and 12. Yeah, 10 and 12. And then page 630. 630. Just looking at my book here for a second. 630, question number 10. Question number 10. Oh, okay, so please do give give those questions a try. Um, I'm working on the solution for, I finished these solutions already. So I will just be finishing this last question up. I will post everything today. I will post the notes that we wrote today, and I also will post the solution today. So you can get that as well today. Okay, so just in case you're wondering on how to do things or if you get stuck or what could be a strategy, I will post a solution today on today's blog. Okay, so I think that's about it. I just want to remind everybody that we only have two more lessons to go. So we only got lesson 7, which is going to be happening tomorrow. And we're going to have lesson 8, which is happening on Wednesday. Um, so keep up with it, and some of you are working, some of you have families, some of you are have other classes besides math. I understand all these things are happening at once. I just want to remind everybody that, hey, we are almost done our course, and we're just so glad that you are still there and still continuing your math, and you did not give up. Okay, so I'm glad that you guys are doing that. Okay, so I don't want to take much of your time. Uh, Use this time now to answer some of these questions. Like I said, if you get stuck or if you have any questions, send me an email. I will get back to you as soon as I can. Okay, so there you go. Have a wonderful day, everybody. And I will talk to you either later today or I'll talk to you tomorrow. Okay, thank you again for watching. Bye for now.